Composite inverse trigonometric functions. In previous studies to prove that two functions f of x and g of x were inverses of each other, we found f of g of x and g of f of x, and if both were equal to x, then they were inverses of each other. Sine, cosine, and tangent functions are not one-to-one. For these functions to have an inverse, they must have domain restrictions. For sine inverse of x, the domain is restricted from -1 to 1. The range is restricted from -π/2 to π/2. For cosine inverse of x, the domain is restricted from -1 to 1, and the range is restricted from 0 to pi. For tan inverse of x, the domain is the set of reals, and the range is restricted from -π/2 to π/2, not inclusive. If x is in the domain of both f and f inverse, then f of f inverse of x is equal to x, and f inverse of f of x is equal to x. As we compose trigonometric and inverse trigonometric functions, keep in mind that inverses undo each other. Also keep in mind that there are domain restrictions on the inverse trigonometric functions. Composing trigonometric and inverse trigonometric functions. Here we have cosine of cosine inverse of 2/3. Our outer function is cosine, and here is our inner function. We need to check to see if 2/3 falls within our domain of -1 to 1. 2/3 does, therefore I know that my inverse is undo each other, and the answer is 2/3. Let's look at the next one. We look at the restriction for sine inverse. It is -1 to 1, and 1 does fall within that domain restriction. Therefore, sine and inverse sine undo each other, and the answer is 1. Cosine of cosine inverse of pi. Well, when we have cosine inverse, we're looking for an angle. This is a number. Pi is 3.14. If I look to see if it fits within the domain restrictions, 3.14 is not between -1 and 1. Therefore, this is undefined. Let's look at the next one. Tan of tan inverse of 5. My domain is a set of reals. It does fit in there. Tan and tan inverse undo each other, so the answer is 5. Here I have sine inverse of sine π/2. My inverse function is my outer function, and sine π/2 is my inner function. Π/2 is an angle. I need to make sure that it falls within my range of -π/2, π/2. I can see that π/2 does fall within that range. Therefore, sine inverse and sine undo each other, and I'm left with π/2. Next, we have tan inverse of tan π/3. My outer function is my inverse function. Here I have tan π/3. This is my angle. And I know it must fall between -π/2, π/2. Π/3 does fall within that restriction. Therefore, tan inverse and tan undo each other, and I'm left with π/3. Next, I have cosine inverse of cosine π/2. I have my inverse function as my outer function. As my inner function, I have cosine π/2. This is an angle, so it must fall within my restriction of my range, and my restriction is 0 to pi. Π/2 does fall within that restriction. Therefore, cosine inverse and cosine undo each other because they're inverses, and I'm left with π/2. Before we tackle the next problems, I want to spiral back and review reference angles. A reference angle is the smallest angle that the terminal side of a given angle makes with the x-axis. So in quadrant 1, I just have theta. That's my reference angle. In quadrant 2, to find my reference angle, I take pi and subtract theta from it. In quadrant 3, I have theta, and I subtract pi. And in quadrant 4, I'd have 2 pi minus theta. Reference angles make it possible to evaluate trigonometric functions outside quadrant 1. Reference angles are always positive, and they're always acute. This is important when we work the next problems. Angles that have the same reference angles always have the same trig values, except that the signs are going to vary. And we use this mnemonic to remember where our signs were positive. Here we have all, cosine's positive, sine's positive, students, cosine is negative, sine is positive, take, both cosine and sine are negative, classes, cosine is positive, sine is negative. 0, 90, 180, 270, and 360 degrees do not have reference angles because they are quadrantal angles. They're on the x and the y axis. Now let's evaluate sine 5 pi over 3. I can easily see that pi over 3 is the reference angle. Remember the statement above where it says that angles that have the same reference angles always have the same trig values. Signs can vary. So I have pi over 3, 2 pi over 3, 3 pi over 3, a quadrantal, 4 pi over 3, 5 pi over 3, and 6 pi over 3. It's what I call my pi over 3 family. Well, here my reference angle is equal to pi over 3. Remember how we found the reference angle above? We said pi minus theta. So 3 pi over 3 minus pi over 3 gives us 2 pi over 3. My reference angle is pi over 3. My reference angle is also going to be pi over 3. And also here, pi over 3. And if I look, sine of pi over 3 is square root of 3 over 2. Sine of 2 pi over 3 is the square root of 3 over 2. Sine of 4 pi over 3 is a negative square root of 3 over 2. And sine 5 pi over 3 is a negative square root of 3 over 2. Note, if the angle is outside the domain, rewrite it using an angle with an equivalent value that is in the domain. We have sine inverse of sine 5 pi over 3. For the angle to be inside the domain, it must fall between a negative pi over 2 to pi over 2. It is restricted to the first and the fourth quadrant. If we draw 5 pi over 3, this is 3 pi over 3. This is 6 pi over 3. My angle is going to land in the fourth quadrant. And my reference angle is going to be equal to pi over 3. In the fourth quadrant, sine is all students take classes. Sine is negative. Where is sine negative, and we have a reference angle of pi over 3. Well, for sine to be negative, it's going to have to fall in the fourth quadrant. It's going to have to fall here. And to have a reference angle of pi over 3, I'm going to go clockwise, and that's going to be a negative pi over 3 is what theta is. Now let's look at the next one. Cosine inverse of cosine of a negative pi over 4. For the angle to be inside the domain, it must fall between 0 and pi. That is in the first and the second quadrants. If I draw a negative pi over 4, I'm going clockwise halfway in between that quadrant. My reference angle would be pi over 4, And in this quadrant, cosine is, all students take classes, cosine is positive. Where is cosine positive in quadrants 1 and 2? Is cosine positive in quadrant 1 or in 2? It's going to be in quadrant 1. It's going to have a reference angle of pi over 4. So my angle is a positive pi over 4. Sine inverse of sine of pi. For the angle to be inside the domain, it must be between a negative pi over 2 and pi over 2. That falls in the first and the fourth quadrants. The angle pi is not inside the domain. Pi does not have a reference angle. It is a quadrantal. Let's look at the quadrantals. For pi, I know that it is a negative 1, 0. For 0 or 2 pi, it is 1, 0. For pi over 2, it is 0, 1. And for 3/2 pi, it is 0, negative 1. Well, sine of pi is 0. On this side, sine of 0 is equal to 0. So our value, if the angle is outside the domain, which this is, we rewrite it using an angle with an equivalent value, which is what we have here, that is in the domain. So it's going to be 0 radians. Cosine inverse of cosine 5 pi over 4. For the angle to be inside the domain, it must be between 0 and pi. That is in the first and in the second quadrant. 5 pi over 4. Here we have 4 fourths pi. We have 8 fourths pi. It is going to be in quadrant 3. I can see that my reference angle is pi over 4. Cosine is negative in quadrant 3. In quadrant 3. To rewrite my angle with an equivalent value, it must be in quadrant 2. Here's my reference angle. This angle is going to be 3 fourths pi. Tan inverse of tan of 7 pi over 4. For the angle to be inside the domain, it must fall between a negative pi over 2 and pi over 2. This is in the first and the fourth quadrants. If the angle is outside the domain, rewrite it with an angle in the domain that has an equivalent value. We can see that 7 pi over 4 does not fall within this restriction. Let's draw our angle. This is 4 pi over 4, 8 pi over 4. We can see that our angle is going to lie in the fourth quadrant. Also, I can easily see that my reference angle is pi over 4. I want to rewrite my angle in a domain that has an equivalent value. It would be a negative pi over 4. And we can see that 7 pi over 4 and a negative pi over 4 are coterminal angles.